Episode 63, titled Federation Basics, SAML and OIDC, the goal is to explain federated login so modern identity scenarios make sense, instead of reading like a blur of redirects and unfamiliar terms.
Federation is everywhere in real organizations because it lets one identity system authenticate users for many applications, including applications owned by other teams or even other companies.
That convenience changes the shape of risk because the trust boundary shifts from this app checks my password to this app trusts what another system says about me. When that trust is configured well, federation is a strong design that reduces password sprawl and improves control.
When it is configured poorly, a small validation gap or claim mistake can become unintended access across many services.
This episode builds a mental model you can use on the exam and in real triage without getting bogged down in protocol trivia.
Federation can be described simply as shared authentication across organizations and applications, where you use one login to access many services.
Instead of creating separate accounts in every application, an organization relies on a central identity system to authenticate users and then vouch for them to other systems. Those other systems may be internal applications, cloud services, or partner applications, and the key is that they agree to trust the identity provider's statements. Federation reduces the need for applications to store or verify passwords, which can improve security if implemented correctly. It also supports a more consistent user experience because users sign in once and then access multiple resources. The security implication is that the identity provider becomes a high-value component because it influences access decisions across many services. If the provider or the trust between provider and applications is misconfigured, the blast radius can be large.
The roles in federation are straightforward when you frame them plainly.
The identity provider is the system that proves who the user is, meaning it performs the authentication step and produces the identity information that will be relied on downstream. The service provider is the application or service that grants access based on that identity information, meaning it decides what the user can do after it accepts the provider's proof. This division of labor is why federation works. The identity provider specializes in authentication and user lifecycle, and the service provider specializes in application-specific authorization and behavior.
The risk is that the service provider can only be as strict as its validation of the identity provider's messages and as careful as its mapping of identity details to permissions.
When you read exam scenarios, a helpful question is, who is doing the authentication and who is doing the authorization? Because federation splits those responsibilities. Once you identify the roles, the rest of the scenario becomes easier to interpret.
Assertions and claims are the packaged identity details passed between systems, and they are the mechanism by which federation communicates this user is who they say they are. An assertion, in this context, is a container that carries identity statements, while claims are the individual details, such as a user identifier, group membership, roles, or other attributes the service uses to make access decisions. The service provider accepts these identity details because it trusts the identity provider to issue them correctly and to protect them from tampering. Claims are powerful because they often determine authorization outcomes, such as whether a user becomes an administrator or gains access to specific datasets. Overly broad claims can create overprivilege, while missing or mismapped claims can create unexpected access patterns or denial of access. From a security viewpoint, claims are not just informational, they are policy inputs, and policy inputs must be validated and constrained. When you see group claim or role claim in a scenario, you should immediately think about least privilege and strict mapping.
Trust relationships are where federation is won or lost because keys and configuration determine what the service provider will accept. The service provider must be able to verify that the assertion really came from the trusted identity provider and that it has not been modified. That usually involves cryptographic verification using keys, but it also involves configuration details like expected issuer, intended audience, allowed redirect or callback endpoints, and accepted claim formats.
Trust is not automatic just because two systems support the same standard, because a standard still requires correct configuration.
If validation checks are relaxed, if keys are mishandled, or if audience and issuer expectations are not enforced, the service provider may accept assertions it should reject.
That is how federation misconfigurations become access problems. The service grants access based on identity packages that should never have been trusted. For exam purposes, remember that the trust relationship is both cryptographic and logical, meaning it involves signatures and also involves correctness checks on who the message is for and where it came from. Common failure themes cluster around misconfiguration, weak validation, and overly broad claims, and those themes often create disproportionate impact.
Misconfiguration includes accepting the wrong issuer, failing to restrict the expected audience, allowing insecure callback endpoints, or mapping claims to permissions too broadly. Weak validation can include incomplete signature checking, skipping important checks like expiration and audience, or trusting unsigned elements due to convenience settings. Overly broad claims often show up as everyone gets admin outcomes due to group mapping mistakes, or as claim values being accepted without confirming they match an approved set. Another failure theme is inconsistent enforcement, where some apps validate strictly while others accept loose federation messages, creating soft targets. In federation, small validation gaps can be catastrophic because they sit at the trust boundary, where a single accepted message can grant session creation and authorization. This is why identity engineers obsess over validation rules, and why attackers look for the app that validates the least. Redirect and callback flows are a conceptual area that matters because mistakes can leak tokens or grant access even when authentication is strong. In many federation designs, the user is redirected between the service provider and identity provider and then returned to the service provider with proof of authentication or authorization. If redirect endpoints are not constrained, an attacker might be able to influence where the proof is sent, leading to leakage of sensitive data or enabling a session to be established in an unintended context. Callback handling mistakes can also allow an attacker to swap parameters, reuse authorization responses, or trick the service into accepting an authentication response that was meant for a different destination. The key is that these flows are built around moving a user agent through a sequence, and sequence-dependent designs are sensitive to misconfiguration. When the flow's boundaries are weak, trust artifacts can end up in the wrong place or be accepted under the wrong assumptions. On exam scenarios, if you see redirect handling, callback URLs, or audience mismatches, think about trust boundaries and strict validation.
Now consider a scenario where a wrong audience claim still grants access unexpectedly because it highlights why validation matters beyond just is it signed. Imagine a service provider is configured to trust an identity provider, but it fails to enforce that the audience in the received identity package matches the service itself. The result is that an identity message intended for a different application can still be accepted, and the service will create a session and grant access. The clue is that access is granted even though the identity package was not meant for that service, which suggests an audience validation gap or overly permissive trust configuration. This kind of issue can appear as users gaining access through unusual paths, or as tokens issued for one app working against another, which should not happen. The problem is not that federation exists, it is that the service provider is not verifying that the message is meant for it. In a risk story, this is a trust failure that can enable unintended access without any password guessing or brute force. Mitigation ideas should focus on strict validation, least privilege claims, and secure defaults, because those are the controls that reduce both accidental and malicious misuse. Strict validation includes enforcing issuer, audience, expiration, signature verification, and any other checks needed to ensure the identity package is authentic and intended for the correct service. Least privilege claims means limiting what claims are issued and accepted, and mapping claims to permissions conservatively, so that a claim mistake does not become an admin grant. Secure defaults means disabling permissive fallback behaviors and requiring explicit configuration for allowed redirect endpoints and claim mappings. These mitigations are effective because they address the trust boundary itself, not just symptoms. They also reduce reliance on user behavior, which is important because users cannot reliably detect federation misconfiguration. When trust and mapping are strict, federation becomes the strong control it is meant to be.
A common pitfall is confusing federation tokens with local application sessions because it leads to the wrong conclusions about where the weakness lives.
Federation messages establish or authorize access, but the application often then creates its own session that represents ongoing trust within that application.
If you assume those are the same thing, you might blame federation for a problem that is actually local session management, or you might miss a federation validation gap because you are focused on cookies and session state.
Another pitfall is treating "it uses federation" as inherently secure, ignoring that federation security depends on correct validation and careful claim mapping.
It is also easy to over-focus on cryptography and forget logic checks like audience and redirect constraints, which are often where real issues hide. On exam questions, clarity comes from separating who authenticates, what identity package is presented, and what session is created afterward. When you keep those layers distinct, the scenario becomes easier to diagnose.
Quick wins often involve tightening claim mapping and enforcing signature checking, because those changes reduce the most common trust failures without requiring a complete identity redesign. Tightening claim mapping means ensuring that only approved claims are used for authorization decisions and that group-to-role mappings do not accidentally grant broad permissions. Enforcing signature checking means ensuring the service provider validates the authenticity of the identity package consistently, not partially, and does not accept unsigned or weakly validated inputs. Quick wins also include enforcing audience validation and restricting redirect or callback endpoints to known good values, because those controls prevent identity packages from being reused or misdelivered. These improvements tend to be implementable as configuration hardening, which makes them realistic for many organizations. They also reduce risk quickly because they close the soft acceptance behaviors attackers and mistakes exploit. In a prioritization sense, validation and mapping are the core levers for federation security.
Reporting language should identify the trust misconfiguration and the resulting access outcome clearly, because stakeholders need to understand what went wrong and how it affected access decisions. You describe what was observed, such as acceptance of a message with an unexpected audience or overly broad claim mapping resulting in elevated access.
You explain the trust gap in plain terms, such as the service failing to enforce that identity packages are intended for it, or failing to validate the package fully before granting access.
You state the impact, which is unintended access or overprivilege that can be exploited without password guessing, and you recommend specific controls, such as strict audience and issuer validation, signature enforcement, and least privilege claim mapping. You also note any constraints, such as limited ability to test across multiple applications, because federation issues can span many services. Clear reporting is especially important in identity work because teams need to know whether to fix the identity provider configuration, the service provider configuration, or both. A good report makes that division of responsibility obvious. To keep the essentials sticky, Use this memory phrase: provider, trust, claims, validation, access. Provider reminds you that the identity provider does the authentication and vouches for the user. Trust reminds you that the service provider's acceptance depends on keys and configuration that define what is trusted. Claims remind you that identity details directly influence authorization and can create overprivilege if mapped poorly. Validation reminds you that strict checks like signature, issuer, audience, and expiration determine whether trust is deserved. Access reminds you that the outcome is session creation and permissions, which is what attackers care about and what defenders must protect. With this phrase, you can interpret federation scenarios quickly and focus on the control boundary that matters. It also helps you avoid chasing irrelevant details when the core issue is trust acceptance.
To conclude Episode 63, titled Federation Basics, SAML and OIDC, remember that federation is shared authentication, where one system proves identity and another system grants access based on trusted identity packages. The security of federation depends less on the word federation and more on strict validation and careful claim mapping, because trust is powerful and mistakes can grant unintended access. When you see redirect flows, audience mismatches, or surprising access outcomes, think about which system is accepting what and whether it is validating the right constraints. The two-party roles can be restated clearly like this. The identity provider authenticates the user and issues identity information, and the service provider verifies that information and grants access to the application. If you can say that plainly, federation scenarios on the exam become much easier to decode and solve.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.